Today, on how it's made. Brass instrument restoration. And excavation buckets. Life on the concert circuit can be punishing, not just for the musicians, but for their instruments. Dents, scuffs, and general wear can ruin the tone of a brass instrument. But with a professional restoration, a badly damaged horn can once again shine in the spotlight. They may look ready for the scrap heap, but incredibly, these not so gently used brass instruments can be salvaged. Technicians will use a combination of techniques to make them look and sound like new. The restoration work starts with the solid steel ball. The technician inserts it in the bore of the saxophone, just under some deep dents. He places a plastic sheet on the dents from the outside. It protects the finish from scratches as he now moves a powerful magnet over the dents. The magnet pulls the ball against the inside of the instrument with such force that it pushes out the dents. After 30 seconds of this magnetic manipulation, the dents are completely gone. Using a series of engraving tools, another member of the team restores the artwork on the instrument. He follows the traces that remain and relies on his own creativity where the designs have completely worn away. He has only one chance to get this right. After all, he can't erase it and start again. This takes skill and a steady hand. The next technician reattaches a key cup to the hinge rod and melts solder into the joint to make the connection permanent. The brass is looking very tarnished, so he buffs the key cup and rod to a mirror finish. What a contrast to an unpolished key below. He now attaches the restored key and rod to the saxophone and screws it into position. He presses the end of the key lever to confirm that it moves as it should. He now inserts a fluorescent light into the body of the saxophone. It will help him find air leaks momentarily. But first, he activates an adhesive with a torch and applies it to the back of a leather pad. He pries an old and deteriorated pad out of one of the key cups. He transfers the new glue-backed pad to the key cup. He closes the key against the tone hole, and the escaping light indicates a leak. So he heats the pad to reactivate the adhesive and shifts it a bit in the key cup. Now the key completely closes the tone hole when pressed. The next thing to be repaired is a key guard foot that's broken away from the horn. This is delicate work, and to resolder it, the technician uses a hydrogen gas torch because its flame is more precise. At another station, a new part takes shape. They carve a brass cylinder to transform it into a new spring barrel for a trumpet valve. He inserts the spring barrel into the top of the piston, and the fit is good. He then places all the trumpet valve parts in a water and solvent solution. He switches on an ultrasonic device, which sends high-frequency sound waves through the solution. Microscopic bubbles bombard the parts and remove oil and grease, which just float away. The trumpet now chills in a cryogenic freezer, where it's an icy minus 185 degrees Celsius, to relieve it of residual stresses. Back to room temperature, the technician inserts a tiny camera into the bore of the horn. It gives him an inside look at the alignment of the piston's ports as he presses the valves. As with any instrument, the proof is in the playing. This sax is sure to meet the approval of crowds of music lovers. Excavation buckets are groundbreaking tools. Attached to the boom arms of backhoes or other heavy equipment, they scoop up tons of soil and rock to make holes in the ground. For jobs like building foundations and laying water and sewer pipes, excavation buckets dig right in. For soil excavation, there's quite a bucket list. Manufacturers make excavation buckets in a range of sizes and profiles. They can have teeth or a smooth blade, depending on the kind of soil they'll be digging. They custom design each excavation bucket on a computer and map out the dimensions. The computer then guides a plasma torch as it cuts parts from high-strength steel. Here, the torch produces attachment plates for holding the buckets to the excavator arms. It even cuts the holes for the pins that will hinge it to a boom arm. Each part weighs over 90 kilograms. A powerful magnet lifts it over to a metal pallet to await some refining. Next, the computer-guided torch carves through a thinner sheet of steel to produce a template. Parts of the excavation bucket will be shaped to this template so they'll match up when assembled. With an oxygen-fueled torch, they bevel the blade to give it the edge it needs to bite into the ground. This blade profile is for sandy soil. A jagged edge is preferred for rocky or clay terrain. Next, it's over to a powerful press. It bends another part into an arch. This arched part will straddle the top of the excavation bucket. Meanwhile, at another station, a press bears down on the beveled blade to shape it to the template. The template is a cardboard copy of the steel one cut earlier. The operator confirms that the first bend is angled correctly. He then sprinkles lubricant and aims the press a few centimeters away from the first bend. It takes 6 to 8 hits to achieve the desired 90-degree angle. Once satisfied, he'll bend the other end to the same degree. Using rollers, the factory transforms a flat piece of steel into the bottom and back wall of the bucket. The operator checks the curvature of the part with each pass until it's spot on. They're now ready to pull all the pieces of the excavation bucket together. And pulling is the operative word. Using chains and a hydraulic system, they pull the sides up to meet the back wall. The steel template is now put to use. It's positioned on the front lower lip and serves as a guide as the chains bend the sides. With the sides now flush to the back, a welder first tacks them together and then does permanent welds. He guides the blade into position at the front of the bucket and welds it to it. When this weld is complete, he'll remove the steel template. The attachment plates have now been linked by thick pins. They lower it onto the top of the bucket, and it fits snugly to the arch and to the back wall. He welds the attachment assembly to the bucket. They paint the bucket inside and out. Yellow or black are popular choices for excavation buckets. Clients usually match the color of the bucket to the machine that moves it. It takes about 50 hours to manufacture an excavation bucket, and then it's ready to hit the ground.